So the next part is the design of special confining reinforcement. Now, when it comes to the design of special confining reinforcement, again we have to know two things. First one is there is something known as area of the core. So we need to know what is this core region, and second one is this length h. I think I discussed in the previous video how to calculate this length h. H is basically the center to center distance of the parallel legs of the stirrups. Okay, so what we have to do is, for example, here I have mentioned the calculation of h. So what we do is, if we the total dimension is 500 mm. So if we subtract two clear covers, we will reach the outer to outer of the longitudinal bars. Now if we subtract 2 times half the bar diameter from the top, so we will reach the center to center of the outer longitudinal bars. So that distance we will be getting, and from that if we divide the whole by 2, so we will be getting 197.5 mm, which will be the h value. So this h value will be 197.5 mm. That is the center to center of these two bars. Okay, so this will be the center to center of these two bars. Same, the center to center of these two bars will also be 197.5 mm. If we find out h in this direction, in this direction, if we find out h, it is still going to be smaller than 197.5 mm. So we want to take the largest h value. So this will be the h value. Now if you go for with regard to core basically means this shaded area. So this shaded area is core. How do we calculate the dimension of the core? Basically it is that whole area which is inclusive of the stirrup. So whatever is coming within and inclusive of the stirrup, that is the core area. So how do we find it? The total diameter is d. Okay, so if we subtract one clear cover, we will be reaching the outer of the longitudinal bar. That is not what we need. We need to go to the outer of the stirrups, so we will be adding a 10 mm. Again from this side also we will be subtracting, from the bottom also we will be subtracting one clear cover, so we will reach the outer of the longitudinal bar. Now we will add one stirrup, we will come to the outer of the stirrup, so that will be the core. So diameter of the core in one direction will be 40 mm. Similarly in the other direction also, 400 minus 40 plus 10 minus 40 plus 10, we will be getting 340 mm as the other dimension of the core. So the core dimension will be 440 mm divided by multiplied by 340 mm. This will be the dimensions of the core. Similar will be the case in which we will be calculating for a circular section also, that I will describe towards the end of the session. Now if we look into the provisions for special confining reinforcement, first one is we will have to choose a length. Okay, so if we have a column length, total length is L, then L0 from either end will be subjected to special confining reinforcement. So this L0 has to be found out. So as per the code, if we look into the provisions of the code we described earlier in the video, L0 has to be the greater of, first one is the largest longitudinal dimension. So here the largest longitudinal dimension is 500 mm. Second one is, it has to be second one is 1 by 6 of the clear dimension of the member. So 1 by 6 of 3000 means 3 meter is the clear dimension of the member, so that is 500. Third one is 450 mm. So the greater of these three is going to be the L0 value. So we choose 500 mm as the L0 value. So L0 is given, and the remaining we have 2 meter. Okay, so in this 2 meter region the spacing should not be greater than the smallest longitudinal dimension divided by 2. So smallest longitudinal dimension we know is 400, that divided by 2 is 200 mm. So the spacing in this region should not be more than 200 mm. Now we need to find out what is the spacing in this region where special confining reinforcement is provided. And as you know, first step is we need to decide what should be the arrangement of special confining reinforcement. So let us look into the figure to understand the arrangement. Here if we already know total 8 25 mm phi and 8 20 mm phi are provided here. And as you know, the dimensions are greater than 300 mm, we will have to provide cross ties in between. So here what I have done is I have provided two cross ties. So this is one cross tie and this is another cross tie. So depending on the number of cross ties provided, we will have to find out the value of h. So h is already calculated as 197.5 mm. Similarly, the dimensions of the core is also calculated. Now once that is done, the next thing required is we need to calculate the spacing of the stirrup. So the spacing of the stirrup should not be more than, first one is 1 by 4th of the smallest longitudinal dimension. So smallest longitudinal dimension is 400. So 1 by 4th of 400 is 100 mm. Second one is it should not be more than 6 times the uh, largest longitudinal bar. So that is 25 mm. So 150 mm and 300 mm. So of these three, the smallest value is 100 mm. So we will choose 100 mm. It should not be more than 100 mm. Now we have two more criterions. First criterion is ASH should be maximum of these two formulae that is given in the code. SV is the spacing of the stirrup, H we already calculated as 197.5, FCK by Fi, AG by AK. AK is the area of the core. We know the dimension of the core, so finding area is not a problem. So what we do is, instead of writing this equation as such, we will rewrite this equation. Instead of writing ASH is equal to maximum of this thing, we will write SV is equal to minimum of these two. We simply rewrite the equation. So now if we substitute ASH, as we know, we are using 10 mm stirrup, so it will be 78.5. 0.18 into H is 197.5 into 25 by 415 into AG we know. AK will be dimensions of the core. So minus 1. We will get it as 108.8 mm. And similarly, there is a second formula. So where also we will apply similarly and we will get 131. So of these three, the lowest value is 100 mm and the spacing should not exceed this 100 mm. So that will be the spacing of special confining reinforcement. So finally what we require is we need to draw the detailing. So in the detailing we will have to show the cross sections clearly with the 135-degree hook as well as the cross ties. Everything has to be shown, okay, clearly. In addition, all the dimensions has to be marked. Then here with regard to this longitudinal dimension we will have to show L0, and we will also have to show what is the spacing in all the different regions. In the center region we are giving based on this criterion not exceeding least lateral dimension divided by 2, and here we are giving the spacing as we found out here. Similarly for circular column, if it is a circular column, the only difference is going to be we will have to find out the diameter of the core, and based on the diameter of the core we have to find out the area of the core. Finding diameter is very simple. Outer dimension is 500 minus 2 clear cover will reach you to the outer point of the longitudinal bars, plus 2 stirrup dimension will take you to the outer of the stirrups. So that will be the core for 40 mm. This is how we calculate the diameter of the core. The formula for connecting ASH and SV will be different and it is given in the code. You can look to it and try to solve problem regarding this. Thank you.